Although quite small, some 5,000 kilometers in diameter, Mercury is near and bright enough to be seen with the naked eye. However, staying close to the Sun, it is not easy to see, low on the horizon, just before sunrise or after sunset. Ground telescopes can discern the planet's surface, but astronomers had to wait for Mariner 10 in 1974 for the first detailed images. NASA's probe innovated, making use of a gravitational slingshot maneuver, swinging by Venus in order to reach its target and repeatedly fly by it, thanks to the calculations of an Italian expert in celestial mechanics, Professor Giuseppe BepiColombo.
He suggested to NASA that with the same amount of propellant and making use of the spatial dynamical situation between Mercury and the Sun, the satellite, the Mercury satellite, could have flown by Mercury itself 3 times instead of 1.
Mariner's TV cameras sent back views of Mercury's surface surprisingly resembling that of our Moon, covered with large and small craters, but no seas or maria and virtually no flat plains. Its most prominent feature is the huge Caloris basin, probably caused by a meteorite impact. Because of its orbit, Mariner 10 could only map some 45% of the surface. Scientists had to wait 30 years to observe the remainder with the Messenger spacecraft launched in 2004. It has flown past Mercury twice in 2008 and will enter orbit around the planet in 2011. Mercury spins on its axis ever so slowly compared to our planet. 2 Earth months to complete 1 revolution. So the planet's day lasts 176 Earth days, and each night is just as long. Only 58 million kilometers from the Sun, its surface during the day is baked to temperatures of 400 degrees Celsius or more, hot enough to melt metals such as lead.
When you want to fly around Mercury with a satellite, you find yourself in a very special thermal situation where you get a lot of heat coming from the planet itself that behaves like a thermal mirror, and then from the side you get the heat from the Sun. So you have 2 heating sources which may destroy a normal spacecraft.
But what is the planet like inside? As a telluric, Earth-like planet, it must have a similar density and structured layer. But its metallic core is much larger, with a comparatively thin, rocky mantle and surface crust. It has a strong magnetic field, and its extremely tenuous atmosphere is hardly detectable. ESA's mission to Mercury, named BepiColombo after the Italian physicist, will pursue the exploration of the planet. Launched by a Soyuz from French Guiana, it is due to set off in 2013 on a 6-year journey before orbiting the planet, then gathering data during at least a year. The mission, conducted in cooperation with Japan, will consist of 2 separate spacecraft.
One provided by us that will enter a very close orbit around Mercury with the capability of really taking images and geophysical and geochemical measurements with unprecedented resolution. And at the same time we will have another satellite on a different orbit, a very elliptical orbit, a spinning satellite that will measure the interaction of the solar wind with the Mercury loose magnetosphere.
After ESA spacecraft today orbiting Mars and Venus, BepiColombo will provide further valuable data on the last and innermost telluric planet. It will fit in the overall framework, understanding the origins and evolution of the solar system, and no less important, how life developed.
In order to understand that, we need to understand the environmental climatic evolution of the different planets, which might have hosted in the past life or may still host life. And then we do comparative planetology to see how the evolution of different planets may help us in understanding the evolution of our own planet.